Welcome back to All This Math. This is Professor Parker. Make sure you are subscribed to the All This Math YouTube channel. Like the video, share the video, tell everybody about the All This Math YouTube channel. All right, today's video is brought to you by the late ancestor, the late great Malcolm X, Omawale Malcolm X. Please read his old speeches. Please listen to his old speeches. All right, if you have not read his autobiography, the autobiography of Malcolm X, as told to Alex Haley, please read that. But in addition to reading that, or even if you haven't read that or have read that, read his speeches, study his words, study his own ideology, his own politics that came straight from his own mouth. I highly recommend. I'm gonna give you two recommendations: the ballot or the bullet speech. All right, the ballot or the bullet speech he delivered in April. I want to say April 9th. I might be off on the day, but April of 1964. Little less than a year before he was assassinated in 1965, February 1965. Also, Message to the Grassroots. All right, those are two key speeches where he lays out a whole lot. He got a bunch of other speeches where he talked about a lot of other things too. But those I think are two good entry points to the philosophies and the opinions. Well, Marcus Garvey had a book called The Philosophies and the Opinions of Marcus Garvey. But of course, Malcolm's parents were Garveyites, so he had that influence anyway. But anyway, those two speeches are a good entry point into the philosophies and opinions of Malcolm X. All right, now for this lesson, we're going to do something called integer arithmetic with number counters, though. Number counters. Now, this is something that a lot of y'all watching this video would consider new math, right? I didn't learn to do an integer arithmetic. And arithmetic, of course, is adding, subtracting, multiplying, and dividing. I didn't learn how to do arithmetic like this when I was in elementary school or middle school. I didn't learn this. Asada, my daughter, if you're not familiar with the channel, my daughter Asada, she be in here on the video sometimes, dancing around, making sure her edges look straight. That little girl, right? My baby girl. She and look, there's some of her artwork right here. You know, she be drawing on the board and everything. But anyway, she brought this home as a homework assignment, and I wasn't too familiar with it. So I said, oh, I need to step my game up. I need to get familiar with it. So I got familiar with it, and I actually like this method because using number counters, it's a good introduction to the concept of how to add and subtract positive and negative numbers. Now, I would not recommend using this when you get to higher levels of math because honestly, you don't got time for all that. But eventually, you're gonna be able to do it. You know, do arithmetic with positives and negatives, addition and subtraction, mentally, real quick. Once you get accustomed to it and you understand what's happening, and you start to understand the relationship between the numbers. You know what I'm saying? So look, let's look at number one. Number one says 5 minus -1. Now, why are there parentheses here? The parentheses are just there just to show that there's separation between this -1 and this minus sign. All right. Also, keep in mind, this is a minus sign, this is a negative sign. But in actuality, minus sign and the negative sign mean the same thing. They communicate the same idea. All right. So be careful with that. Don't let that confuse you. Because a lot of students say, but I thought this was a minus sign. I thought that was a negative sign. Actually, they kind of represent the same thing. All right. So this is a 5, which is a positive 5, right? When there's no symbol in front, that means it's a positive 5. So you got a positive 5, and we want to take away a -1. How are we going to do that? All right, so we're going to use number counters. So first what we do is we draw some circles with some plus signs inside of them. And those circles with the plus signs inside of them are going to represent the positive 5. So we're going to draw 5 of them. All right, I'm going to use the colors. What color should I use? I'm going to just use black and purple. I'm going to use black for positives. I wish I had a red marker. I don't got my red marker down here. I would use red for negative. But black for positive and purple for negative. So I'm going to draw 5 circles with plus signs in between. 1, 2, 3, 4, 5. Now again, why did I just draw 5 circles with plus signs inside of them? Because that represents this number 5, this positive 5. 1 positive, 2 positives, 3 positive, 4 positive, 5 positives. All right, I didn't draw 6. Why didn't I draw 6? Because that's not a 6, that's a 5. I didn't draw just 4. Why didn't I draw just 4? Because that's not a 4, that's a 5. I didn't draw 10. Why didn't I draw 10? Because that's a 5. So however many, if you start out with a positive 5 in your expression, you should have 5 positives. Now, what are we trying to do? We're trying to take away a -1. I don't see no -1s. I don't see no circles with negatives. All right? When you encounter that situation, this is what you got to do. This is the key to this, right? When When you encounter that situation, when you're trying to take something away that does not exist or is not illustrated, you got to create what's called a number pair. A number pair. A number pair is when you have a positive and a negative. Positive circle and a negative circle. That's a pair. It's two of them, like a pair of shoes, left shoe, right, right? Positive circle, negative circle. Whenever you encounter that situation. And I could just randomly just draw one up there. You know why? Because it doesn't change the value of this expression. If I put a positive and a negative, in reality, those would cancel each other out. So technically, it looks like I added a positive one and a negative one, but I really ain't add nothing because those two actually cancel each other out and become zero. So again, when you encounter a situation where you're asked to take something away that does not exist in the currently in the problem, you use what's called a number pair. Sometimes sometimes you need to draw one number pair. Sometimes you need to draw two of them, three of them, four of them, five of them. It depends on what the problem originally said. So I need to take away one. So in order to do that, I can't just randomly just write a negative one up there because that would change the problem. I don't want to change the nature of the problem or the value of the problem. What I want to do is I want to keep the value of the problem the same, but I want to represent this negative one. So this is what it's going to look like. I'm going to have oh yeah, I said I was going to put the negatives in purple. So I'm going to switch up on you. Right? So I'm going to draw a circle with a negative sign in it. All right, so I got a circle with a negative sign. And then, because it's got to be a pair, I'm going to put a plus sign, a circle with a plus sign. So this is a number pair, right? These two go together, right? They're a number pair. So now, check this out. What I can do is this minus sign is a subtraction sign, which means take away, right? So if I'm taking away a negative one, what do? Now I can take away this negative one, right? I take away this negative one. So I'm going to take my marker. I'm going to draw a line through that. Boom. I took it away. I imagine it's not even there because I drew a slash through it, right? Now the question is, what is left? What is left? 3 words. That question. What is left? 1, 2, 3, 4, 5, 6. 6 positives. So that means that the answer to this question is positive 6. And that's how you add it. That's how you subtract using number counters. Number counters. Now look what I did. Let's recap. Let's run it back. I started with number 5. This is 5, right? Positive 5. So I got 5 positive circles. 1, 2, 3, 4, 5. These are the number counters, right? And then it's asking me to take away a negative 1. But I can't take away something that's not there. I didn't have no negative 1s. So I had to create what's called a number pair. Number pair. Number pair. I keep saying it, right? Because it's important. I keep emphasizing it. Whenever you got to take away or even sometimes add something that's not there, right? You might be adding a negative sometimes, right? You got to create a number pair. Now, again, I told you why you got to do that. Because I can't just randomly just put a negative 1 up there because that changes the nature of the question, right? I got to put a number pair to indicate that this does not change the value. It don't change the value because that positive and negative would naturally cancel each other out anyway, right? But it's not going to cancel each other out because what I'm doing is I'm taking away what? I'm not taking away the positive 1. I'm taking away a negative 1. I'm taking away a negative 1. Once I do that, draw the slash through it, then I count what's left. I count what's left. I'm left with positive 6 positive circles. And that's how you do subtraction with number counters. I know a lot of people are going to say, oh, why we can't just do it the old way? Why we can't? You can. But again, it's important for your children to know different ways of problem solving. I'm going to say that again. It is important for your children to know different ways of problem solving. So don't be scared of learning new methods. Do not fear new methods. Embrace new methods. Because I'm going to tell you this. The more methods your children learn how to do things, the better they'll understand the previous methods, right? A lot of us only know one way to do something. And some of us don't really even know it that well. So what happens is we encounter certain problems that are a little bit confusing, and then because we don't really understand the concept beneath the math that we learned years ago, because we think we're smart, like, oh yeah, I know how to do this, right? But you only learned how to do it one way. If you knew how to do it 3 or 4 different ways, then when you see a problem that's a little more challenging, then you'll be able to figure it out and understand, like, oh yeah, because that's only doing this, because that just looks like that, because it is blah, 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 right? But a lot of us can't do that. So again, don't set your children up for failure. Let them learn the different methods, right? Let's not be anti-intellectual. Let's not run away from different methods of doing things. Like, what is it going to hurt for real? What's it going to hurt? Ain't nobody saying, like, one way is better than the other. You got to determine what the best way is. but it's important to know the different methods, right? So you can make that determination. All right, let's get into number two. Number two, -7 take away 2. Now, be careful with this one. So I start out with -7. -7. So I'm doing 7 negative counters, or negative circles, negative counters. All right, 7 of them, because I got a -7. So let's draw that on your paper. If you're working along with me at home, draw 7 negative circles. All right, so we got like this: 1, boom, 2, 3, 4, 5, 6, 7. Right, we got 7 of them. Right. Now I want to take now here's where we gotta be careful. All right, you gotta be real careful with this, right? Because this says -2. So technically, notice I said heavy on the word technically, right? Technically, this is a +2, right? I'm taking away +2. Even though if I was doing this a different way, I would just treat this like a -2. You know what I'm saying? Because it really is a -1 times +2, which yields us -2 anyway, right? But for the purposes of this method, we're gonna look at it from a technical standpoint. This is technically a +2. We're taking away a +2. We're taking away 2, right? But look down, lo and behold, I don't see no +2s. So what I'm gonna do? When I don't see what I need, I draw number pairs. Again, when I don't see what I need, I draw number pairs. All right. So I'm gonna do 2 number pairs. Up here I only did 1, because I only needed a -1. Now I need a +2, so I need 2 +2s. But I can't just write a random 2 +2s. I gotta put 2 -2s to match up, right? We gotta match up. So I'm gonna put positive, and I'm gonna put positive. I'm gonna leave space, because you know why I'm leaving space? Because I gotta put my negatives in there, right? So I got my +1 and my +1, which is my +2, which is this. But I can't just put +2. So I got to have a -1 also and a -1 also, because they got to match up. They got to match up, because that doesn't change. Because by doing it that way, using the number pairs, it doesn't change the value of the original expression, right? We don't want to change the value of the original expression. So now I got -7, right? And I want to take away what I want to take away or get rid of, +2. So I look for my +2 right there and right there. Boom, boom. I took them away. Now I count. What's my last step? Count what I got left. What do I have left? I got these original 7 negatives, and I got these 2 negatives. Altogether, that's 9 negatives. 9 negatives means my answer is -9. Draw a box around it. So -7 minus 2 is -9. And I know somebody's sitting there watching this video like, oh, why we got to do all that? Why we got to do all that? Listen, this is an introductory method, right? To help young children understand the concept of adding and subtracting positive and negative numbers. Of course, shouldn't nobody be in 12th grade in high school drawing out number counters, right? But in the beginning, it's kind of like training wheels. Think about training wheels, right? First, try to teach a child how to ride a bike, put the training wheels on, all right? Helps them to understand, balance, understand like how to pedal and whatnot, gain comfort on a bicycle. Then eventually what you do, take the training wheels off. Take the training wheels off. You might just take one training wheel off and let them ride. You might take both of them off and then let them ride. See what happens, right? These are training wheels. There's nothing wrong with training wheels. They're not going to be using the training wheels forever, right? It's just another method to help to explain the concept of what happens when you're doing integer arithmetic. And again, an integer, quick little vocabulary piece, is a number that has no fractions or decimal parts, and no fraction or decimal components. So like 5 is an integer, -1 is an integer, -7 is an integer, +2 is an integer, right? 3.2 is not an integer because it's got a decimal part. 7.8 is not an integer because it's got a decimal part. 3/4 is not an integer because that's a fraction, and a fraction and a decimal are equivalent. All right. 8/3 it's an improper fraction, but it's still a fraction, so it's not an integer. Integers do not have fraction or decimal components. I was going to do a couple more examples, but this video getting a little long. We already 15 minutes in. Time flies when you're having fun, right? So I'm going to cut it right here, and I'm going to do another video with some more examples of this. But this is how you do addition and subtraction with positive and negative numbers using number counters. Remember, think about when to use number pairs. You use the number pairs when you don't already have what it is you're trying to take away, or you don't already have, what you're trying to take away. We didn't already have a -1, so we used a number pair for that. We didn't already have a +2, so we used a number pair for that. One pair, 2 pairs. That's where we get the positive 2 from. So then we could take it away, right? And again, I want to emphasize this. You can't just draw 2 positives, because then that wouldn't be the same problem. Because then what you'd be doing is doing -7 plus 2. If you just draw 2 random plus circles up here or plus counters up here, then you've created a different problem. You don't want to create a different problem. You want to maintain the same problem by using number pairs, because the number pairs mean that you haven't changed the value, right? Because a positive and a negative in reality would cancel each other out anyway. All right. Now, it might not make sense. It might make sense, but go do a bunch of practice problems. Do a bunch of practice problems, and I'm telling you, it will sink in. All right. So remember, study Malcolm X, read his speeches, listen to his speeches. They on YouTube, just like I am. You know what I'm saying? And practice integer arithmetic with some number counters. All right. See y'all later.